Welcome to Star Chat, the podcast where we explore the wonders of the universe and all its secrets. I'm your host, Carl, and I'm excited to share another fascinating episode with you today. As we begin, let's take a journey back in time to June 30th, 1908, when a massive asteroid impact occurred in Siberia, flattening an astonishing 830 square miles of forest. This event, known as the Tunguska explosion, is still considered the largest asteroid impact in recorded history. The impact was so powerful that it released energy equivalent to 10-15 megatons of TNT, which is roughly 1,000 times more powerful than the atomic bomb dropped on Hiroshima during World War II. The Tunguska event has been a topic of interest for scientists and researchers for decades, and recent studies have shed new light on this catastrophic occurrence. By analyzing data from the impact, scientists have gained valuable insights into the behavior of large asteroids when they enter Earth's atmosphere. This knowledge is crucial in helping us prepare for potential future asteroid threats. In fact, NASA and other space agencies around the world are taking proactive steps to detect and track near-Earth objects, or NEOs, that could potentially pose a threat to our planet. The Double Asteroid Redirect Test, or DART mission, which launched in 2021, was a groundbreaking experiment that demonstrated our ability to deflect an asteroid's trajectory. And just recently, the European Space Agency's Hera mission launched, which will study the aftermath of the DART impact and provide even more valuable data on asteroid behavior. As we continue to explore and understand the universe, it's essential that we prioritize asteroid research and develop strategies for mitigating potential threats. The Tunguska explosion serves as a stark reminder of the importance of being prepared for the unexpected. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat, where we explore the wonders of the universe and the latest discoveries that are shaping our understanding of the cosmos. I'm your host, Carl, and we're glad you're joining us for this fascinating journey. Today, we're going to talk about a mystery that has puzzled scientists for a long time: the search for meteorites from Mercury. Yes, you heard that right. Despite being the closest planet to Earth, we've never confirmed a single meteorite that originated from Mercury. It's as if the planet is hiding its secrets from us. But, as always, scientists are not ones to give up easily. A new study has found two unusual meteorites that could potentially be from Mercury. The meteorites, named Xar-Gilan 22 in northwest Africa, 15,1915, were discovered in Tunisia and Algeria respectively, and they exhibit some intriguing similarities to the planet's crust. The researchers behind the study found that these meteorites contain olivine and pyroxene, minor albidic plagioclase, and oldhamite, all of which are consistent with predictions for Mercury's surface composition. Additionally, their oxygen compositions match those of aubrates, a type of meteorite that is thought to have originated from a large planetary body, possibly similar to Mercury. Now, before we get too excited, it's essential to note that linking any meteorite to a specific planet or moon is extremely challenging. It's like trying to find a needle in a haystack, except the needle is a tiny rock from space, and the haystack is the vastness of the universe. However, if these meteorites do indeed originate from Mercury, they could provide us with a wealth of information about the planet's crust, its mineralogical and geochemical composition, and even the nature of its gases. It's like having a piece of the planet itself, right here on Earth. The origin of these samples is likely to remain a subject of debate within the scientific community, and we can expect more research and discussions in the coming months. The Bepi-Colombo space mission, currently orbiting Mercury, may also provide some clues that could help us determine the ultimate origin body for these meteorites. As we continue to explore the universe and push the boundaries of human knowledge, stories like this remind us of the awe-inspiring complexity and mystery of our cosmos. The search for answers is what drives us forward. And who knows? Maybe one day, we'll uncover the secrets of Mercury's elusive meteorites. Stay tuned for our final story of the day, right here on Star Chat. Welcome back to Star Chat, folks. We've had an amazing conversation so far, and I'm excited to dive into our final segment for today. As we explore the wonders of space and science, it's essential to acknowledge the incredible stories that inspire us to reach for the stars. Today, we're going to talk about a film that has become a classic in the world of space enthusiasts, Apollo 13. Directed by Ron Howard and starring Tom Hanks, this movie tells the story of the Apollo 13 mission and its heroic recovery from a potentially disastrous accident. But what makes Apollo 13 so special? For Jennifer Ouellette, a senior writer at Ars Technica, the film is more than just a movie. It's a gateway to sparking people's imagination and interest in space exploration. As she puts it, if you want the public to support space exploration, crucially, for Congress to fund it, you need to spark their imaginations and invite them to share in the dream. Lee Hutchinson, a docent at Space Center Houston, also shares his unique perspective on the film. As someone who regularly gives guided tours of the Saturn V exhibit, he often references Apollo 13 to explain complex technical concepts to visitors. The movie has become a common touchstone that helps people understand the amazing achievements of the Apollo program. While some might criticize the film for its historical inaccuracies, both Jennifer and Lee argue that these creative liberties are necessary to make the story accessible and engaging for a broader audience. As Lee says, the movie amps up the drama in all respects, adds dialogue no astronaut or controller would say, mashes people together into composite characters, but they're also necessary additions in order to get one's hands around a messy historical event and fit it into a 3-act structure. So, what can we take away from the story of Apollo 13? It's a reminder that even in the face of adversity, human ingenuity and determination can lead to incredible achievements. As Jim Lovell says in the film, it's not a miracle. We just decided to go. That's all for today's Star Chat. Remember to like, share, and subscribe, and until next time, remember to keep looking up at the stars.